Okay, good day, viewers. Thanks for watching. Remember, we are still on set, and I told you that I'm going to take the subtopics on set one after the other. So, in today's class, I want us to learn Venn diagram and operations on set. That is Venn Venn diagram and operations on set. Do you understand now? So, this is what I want us to learn today. Venn diagram and operations on set. You get? So now, what is a Venn diagram? Venn diagram is an instructive diagram that depicts, or should I say, that shows the informations in relation to set problem. And this Venn diagram was discovered by two men. One, John Venn. The second person is Leonard Euler. That is Leonard Euler. Second person is John Venn. But it is popularly known as Venn diagram. Did you get? Now, this Venn diagram is used to illustrate and to show informations on set. Did you get? Now, you can use this. If you have something like this, and we have something like this, and we have something like this, and this is A, this is B. Here could be C. Just know that this Venn diagram is always here is universal set, and Venn diagram is always we use rectangle to represent Venn diagram, and we use circles in the Venn diagram to represent either intercept, union set, complement of set, disjoint set, whatever. You understand now? So we use rectangle to represent Venn diagram, and this place U is universal set. So inside it now we have circles. Did you understand now? So anytime you hear Venn diagram, just know that Venn diagram comprised of circles enclosed in a rectangle. Venn diagram comprised of circle Venn diagram comprised of circles enclosed in a rectangle. Did you understand now? So the diagram, we have the universal set represented. Do you get? So now, there are things I want you to know before we go deeper into this. We want to say that A is contained in B. That is that A is a subset of B. We're going to say that is A contained in B. That is to say that A is a subset of B. We're going to draw a circle like this and then put small circle inside. Here is A and here is B. This is to show that A is contained in B. Did you get now? Good. Now we can also, if you want to say that A is not contained in B, want to say that A is not contained in B, we can use a circle like this. That is to say A not contained in B. We can use a small circle like this. This is A, and this is a what? B. Do you observe that they are different on their own? We can also use something like this. We can use something like this. This is A, and this is B. This is A not contained in B. We did something we call subset and superset in our last subtopic on set, right? So there we learned a lot of things there. Do you get? So now let's use a practical example. Example: if I have if A if A is equal to 1, 2, 3, 4, and B is equal to 2, 4, 6, right? 2, 4 what? 6. Now, and we are going to draw a Venn diagram. We'll draw a Venn diagram. Remember we said that Venn diagram comprises of circles enclosed in a rectangle. Now, we draw another circle here. We call here A. We call here what? B. Now, observe that I have 1, 2, 3, 4. I have 2, 4, 6. 2, 4 is here. 2, 4 is here. So here I'm going to write 2, 4. This side now in A, only one. Only 1, 1, 3, right? And this side is only what? 6. What do you observe here? What? What do you observe here? This is to tell us that common numbers here is 2, 4, right? That is to say that A is D is contained in A. Because 2, we have 2 in A. We also have 2 in B. We have 4 in A. We also have 4 in what? B. Now let's talk about union sets. Union set. This excuse me. These are type of sets that are under Venn diagram and operations on sets. We have union sets, we have intersection, right? We have disjoint sets. We have complement of sets. We've done that one in our previous video. So in our previous class. So here now I want us to do all these things because they involve Venn diagram. So union sets, before I commence on this, I want to strike a balance using physical analogy, right? Now, good. I believe you've seen two different political parties coming together to form one party. It had happened in Nigeria. And it has happened. Yes, good example. God bless you. I have seen and we have seen banks. You see banks now. They will come together they will merge, become a single bank, one bank, either due to poor management or whatever. Like Access Diamond in Nigeria. Access Diamond merge. Now they're answering Access Diamond. That is union set. We have set of shoes, set of clothes. If they are set of shirts, we have short sleeve shirts, we have long sleeve shirts. All of them are what? Shirts. If you want to specify or differentiate them, you cannot specify by saying that these ones are short sleeves shirts, these ones are long sleeves shirts. You don't understand the point now? Again, I have used politics and I have used banks, institution. Now, in churches, that is in churches, in Christianity now, you hear non-denominational program, which means if you're a Catholic, you can come. If you are an Anglican, you are welcome. If you are choosing, you are welcome. Irrespective of your denomination, this is non-denominational program. That is union set, bringing different sets, bringing different things together to make it one thing. Is what we call what? Union set. Did you understand that analogy now about union? Huh? So by the word definition, we can say that union set is two different sets coming together to form what? One set. Let me say set A or set B or set C. Huh? When they come together, they form what? One set. Example. Now, and the symbol here is, look at it now. Let me just write, by the way of definition, by the way of definition, this simply means bringing two sets to form one set. And we cite example, we use example two political party two political parties coming together to form one party, to form another new one party. I think that is the way APC was formed in this country, right? In Nigeria. People that have formed APC are from different parties. We have ACN, we have PDP. Many of them came together and formed APC, right? Now, I banks, maybe merging two banks together, merging two banks together. The last but not the least is non-denominational gathering, churches. Like we have Koinonia, and everybody can go to Koinonia. You get Richard Semans, Apostle Richard Semans, this team ministry. Everybody can go there. Koinonia, you get. Yes, now. So merging two different people together to become one people. That is union set. You know, when we teach mathematics, we need to apply it to your day-to-day activities. You need to bring it to your knowledge. We are giving you the tools now to know that this thing is not far from the truth. It's not far-fetched. It's something you know already. Now, let me clean here. Sorry. Stay with me. So now, union set can be represented by two ways. Union set can be represented by two ways. Let me say there are two different ways of representing union set, of representing union what? Union set. One is by shading. Second one is by listing method. We're going to solve a question now that will show us what we said. We get listing the method is by using elements. We can say listing the element. Now for example now, this marker is not writing here, but I'm going to fill it. For example now, if A is equal to 1, 2, 3, 4, 5, we're going to say 7, 11, for instance. And now B is equal to let me say 2, 3, 4, 5, 9. Any number of your choice. 2, 3, 4, 5, 9. let me say 10. Do you get? Now, if we are to solve this by union, we said by listing method or by shading. Did you get now? By listing method or by shading. Now, remember that the symbol for union set is something like this. Let me put it here. Use something like this. That's the symbol for union set. So here now, observe that I have A. A is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 7, 11. Sorry. 1, 2, 3, 4, 5, 7, 11, right? And B is 2, 3, 4, 5, 9, 10. Did you get? Good. So, you know that A here now, A union B will be equal to, we are going to list everything here first. But A union B, let me use Venn diagram. Let me use Venn diagram to represent it first. Or should I just do it this way? Let's put everything there. A union B is just 1, 2, 3, 4, 5, 7, 9, 10, 11. That is everything here. Everything here. I was still clean here. So, so here now I'm going to use a Venn diagram to represent what we have there. Did you get? So using Venn diagram now, excuse me, we have something on this nature, right? Now, there are two things here. We have 2, 3, 4 here. 2, 3, 4, 5. We have 2, 3, 4, 5 here. So for A, here will be 1, 7, 11, right? So for B, here is A, here is B. For B, here will be 9, 10, 9, 10, right? 9, 10. So you have 2, 3, 4, 5. So we said by listing the elements, or we say listing method. We also say by shading. You can decide to shade here. Or I will leave it. Did you understand that? I can decide to do what? Shade here or leave it. So that is union set. So what are we trying to say? Now these two sets, these two different sets now, they have two things in common, which is what? 2, 3, 4, 5. Did you understand the point now? Good. So the next one in our agenda is intersection of sets. Is intersection of sets. So let's talk about intersection of sets. Intersection of sets. Intersection of sets. Intersection of what? Sets. How do we explain this? We explain this by using simple analogy again. Now in the secondary school, if principal wants to know the number of students offering physics and maths, the method of knowing that is application of knowledge of sets, and that knowledge of sets is the knowledge of intersection of sets. Did you understand? Good. Now, let me say, in a secondary school, if the principal wants to know the number of students offering physics, mathematics, eh? Number of students offering physics and what? Mathematics, eh? And that is in SS3. Let me say in SS3, eh? In SS3, what are we going to do? Let's use this as case study. Let me clean this side. Hmm? I don't need to, let me not clean this. I'll use this circle. Eh? So to find out the number of students offering so here now to find out the number of students offering physics and physics and mathematics in SS3. What do we do? What do we do? First of all, we are going to list the number of students offering offering physics. We'll list number of students offering mathematics. So what do we do then? We're going to say P is for students offering physics, right? Then M. So that means here I'm going to use P and M. Do you get? I'm going to clean this B and A. So here is P and here is M. So M now is number of students offering mathematics. But mind you that we want to find out number of students that are offering both mathematics and what? Physics. So what do you do then? We call that one C. C is equal to number of students. We call it students offering, call it students offering both physics and maths. So we're going to use the Venn diagram here. So number of students offering both physics and maths is C. So that is C equals to physics and maths. That is intersect. Did you understand now? That is what? Intersect. That's why we shared it. So what is intercept then? Intercept now is trying to know the bond between two things. Unlike union set. Don't let union set confuse you here. Did you understand now? Don't let union set confuse you here. So when we are going to start learning problem involving set, like two set problem, you're going to learn better. But for now, I'm on Venn diagram and operations on sets. So this is intercept. Let me give you clear example using numerals, numbers, so that you understand. I need to clear. I'm managing my board. My board is small. My board is small. Let me clean. Well, I still clean here. Let me leave that side. Now, in intercept, you need to know that the symbol is something like this. Unlike union set, you said the symbol is looks like you. So the symbol of intercept is opposite union set. Is opposite of what? Is opposite of union set. Excuse me. So now, for example, for example, if A is equal to A, E, I, O, U, that is vowel. That is what? You know this vowel. And B is equal to A, B, C, O, U. Eh? Now the intercept, that is A intersect B with B. Let's use our Venn diagram. When we use Venn diagram, eh, remember we enclose, there are two circles enclosed in the rectangle, right? So here now, we call here A, we call here B. Eh? What is common here? O, O, U, eh? And A, O, U, eh? A, O, U. Eh? Now, other things that you didn't see here, I did not see E. The E is not here. Write E here. EI. Here we're going to write what? B, C. Do you understand now? So this is the intercept. This is the what? So this is the one we're going to shade. So here we're going to shade this one to show you that this is intercept. But it's not necessary that you shade it, but you need to know. So here we're going to say that the intercept is what? A, O, U. Do you get that? So should I give more example? Should I give more example? Okay, one more example. Okay. Where's my duster? Let me clean here. You say one more example, right? You need to soak this. Soak this thing fast. There's still water there. Okay. What now? More example. If we have that, if another example, if x is equal to 1, 2, 3, 5, and y is equal to 2, 3, 6, 7. And let me use z again, and z is equal to maybe z is equal to 4, 4, 8, 9. Now, I will not use Venn diagram here. I'm going to strike a balance on it. That word intercept. so that anytime you want to use Venn diagram, you know how to apply it. So I'll not use Venn diagram here. I want to just let you know more about that intercept. So now, x intersect y. Eh? You know I have 1, 2, 3, 5 here, and I have 2, 3, 6, 7, right? So this will give us 2, 3, right? This is the s intercept y. Now, what of y intersect z? Eh? Y intercept z. This is none. It's a closed set. Why? Because there's no intercept here. Did you understand now? There's no what? Did you understand that on intercept? Any question? Any question? I want to proceed to disjoint set. I want to proceed to what? Disjoint set. After disjoint set, I will then talk about I'll speak on difference of sets, and lastly complement of sets. Do you get? So now let me talk about disjoint set. That will not take us much of our time. Disjoint set. So disjoint set. In disjoint set, if if two sets A and B are disjoint, or you say are disjointed, are disjoint, it means that the elements in A are not the same with the elements in B. Or you can say the elements in A are not contained in the elements in B. This disjoint set is similar to empty set or null set. What did I say? Again, for the last time. Because I know I have taught you empty set, I have taught you null set. And you know that in null set, we have a symbol to represent null set. And likewise, empty set. So the same thing applicable to disjoint set. So now, in disjoint set now, example, I, A equal to boys, comma, B equal to girls. So A intersect B is equal to what? Is disjoint. It is what? Disjoint. It is empty. It's not a set, it's empty set. Again, we have x equal to vowel sound, you know vowel now in English. And y equal to, let's say, consonant. So x intercept y is also what? Is disjoint, is empty. Last but not the least, when you have something like this, if P is equal to 1, 2, 3, 4, and M is equal to 5, 7, 8, 9. P intercept M is disjoint, is empty, is also equal to this. Eh? Did you get that? What is that on disjoint set? So let's talk about difference of set and complement of set. Then, when we are done with that, that means we've done justice to Venn diagram and operations on sets. In my next class, I'm going to teach what we call application of Venn diagram slash two set problem. I'm going to teach two set problem and three set problem. If you master these two things, there's no question on earth on set you cannot solve, no matter how the question was set. No matter how they set the question, you can solve it. Let me clean the board. Pause here. So in difference of set, this means all elements in A, all elements in A that 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 does not that doesn't belong to B. Do you understand? It also means it means element belonging to A but not found in B. That is difference of set. That's why I use A minus B or A minus B. That is, I use this and that. So here, let's use example. For example, let me use X and Y, right? If X is equal to, for instance, let's use 1, 2, 3, 4, 6, 8. Now Y is equal to 1, 2, 5, 7, 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let's put 10 here. So to find difference of set, remember we said all elements in A that doesn't belong to B. Do you understand? That does not mean that you won't find an intercept there. You won't find element in A that is in B. But we are saying that this element does not belong to B entirely. So now let's use Venn diagram. In Venn diagram now, here is A, here is X, and here is Y, right? So now X now, we have 1, 2 here. We have 1, 2 here, right? We're going to write 1, 2. But in X now, we have 4, 6, 8. Is that correct? 4, 6, 8. In our Y, we have 5, 7, 9, 10. 5, 7, 9, 10. Now, if the question says question says find I X minus Y. So this is the answer. We're going to shade this part. When we shade this part, this thing means S minus Y. Did you understand? It means what? S minus Y. Do you get the point now? Good. But if you're not to shade, in fact, you must shade S minus Y. Now, if we are asked to find Y minus X, this is I. Now, I set Y minus X. We're going to draw another Venn diagram. We'll draw that Venn diagram. we put our circles. This is X, this is Y. Now, in X, we have 4, 6, 8. We have 1, 2 here. In Y, we have 5, 7, 9, 10. So this is the answer here. We're going to share this one. So this is Y minus S. Hope you understood this. This is difference of sets. This is what? So let's talk about complement of sets. The last but not the least. Complement of sets. Complement of sets. Here, let me explain because I don't have space. I would have written something on the board, but I don't have space. Let me explain. In complement of sets, all sets of A do not belong to A. Rather, it belongs to universal sets. So this set now, this type of set is in relation to universal set. I need to write. This type of set is in relation to universal set. So here, if we have set A, it means that all sets of A do not belong to A rather to come in. Close it, close. Do not belong to A rather to, you're welcome, to universal set. Did you get? So that is to say A contain U. Did you understand now? Did you understand now? So now, example of this. For example, if the universal set is equal to 1, 2, 3, 4, 5, 6, A is equal to 1, 2, 4, 6. What are we going to do? Using Venn diagram now. Remember we said that all sets of A do not belong to A, rather to universal sets. So here is universal set. And we have A here. So here now, A complement is equal to 3, 5, 2 of us. And use this thing A like this, or A, C. A superscript C to denote complement. To denote what? So these are the things you're going to use to denote complement. So what do? Here is A, then put a bracket here. When you put that bracket here, you're going to write 1, 2, let me write it bold. 1, 2, 4, 6. Remember I have 1, 2, 4, 6. 1, 2, 4, 6. But 3, 5 is not here. So that means all sets of A do not belong to A, rather to the universal set. So now, 1, 2, 4, 6 now belongs to this universal set, but this 3, 5 is not here. So this 3, 5 now, we're going to write it here. 3, 5, and we are going to change this portion. Do you understand now? So that is complement of set that I told you about. So let me give you another example. That means I need to clean here. Let me clean here. Let me give you another example. Another example. If this is equal to universal set is equal to undergraduate, and B is equal to female graduate, that is female undergraduate, so that means B complement will be equal to male undergraduate. So we'll draw our Venn diagram here. We're going to have, this is B, universal set. We're going to have here. What are we going to have here? No. Here will be male undergraduate. Let me write it for you. Here is male undergraduate. You see, there will be what? There will be female undergraduate. So you're going to shade this portion. Did you understand? So that is that on complement of sets. So I really appreciate you for watching. Please don't forget to subscribe to this channel and give this video thumbs up. See you in my next class, because in my next class I will teach two set problem. Thank you.